Every circuit board is full of tiny chips talking to each other, and they are all speaking one of these six languages. UART. UART is the simplest way two devices can send data back and forth. It's been a staple of electronics since the early computing era. Long before USB existed, its main strength is simplicity. Just two wires, TX and RX, cross between devices, plus a shared ground. It's a synchronous, meaning there is no clock wire. Both sides just agree on a speed ahead of time. However, UART only works between two devices at once, so it doesn't scale to bigger networks. Oh, yeah. Most Arduino boards still use UART just to talk to your computer over USB. SPI. SPI is a fast synchronous protocol built for short range, high speed data transfer. It was developed by Motorola in the 1980s for connecting microcontrollers to peripherals. Its strength is speed. A shared clock line keeps every device in perfect sync. So, data moves quickly and reliably. It uses four lines: clock, data out, data in, and a chip select line to pick which device is talking. However, SPI needs a separate chip select wire for every device, so it gets messy with lots of components. 12C. 12C is a protocol built to let many chips share just two wires. Philips created it in the 1980s to simplify wiring inside TVs and other consumer electronics. Its strength is efficiency. One data line and one clock line can addresses dozens of devices, each with its own addresses. It relies on pull-up resistors to keep both the lines stable when idle. However, 12C is slower than SPI, so it's better suited to sensors than the high-speed data like displays. CAN or CAN. CAN or CAN or Controller Area Network is the protocol that let dozens of modules in a car talk without a central computer managing every wire. Bosch developed it in the 1980s specifically to reduce wiring complexity in the vehicles. Its strength is reliability. CAN uses two wires, CAN high and CAN low, and can survive electrical noise that would corrupt other protocols. So, it's also built for multiple devices on one shared bus. However, CAN was not designed with strong security in mind, which is now a real concern in connected cars. RS-232. RS-232 is an older serial standard that predates UART's common use in modern electronics. It dates back to the 1960s, originally connecting computers to modems and printers. Its strength was standardization for decades, and the DB9 connector was a universal way to wire up serial devices. It works similarly to UART, but at much higher voltage levels, roughly plus or minus 12 volts. However, that higher voltage makes it incompatible with the modern low voltage chips without a converter. One wire, this is the last one. One wire is a protocol that does exactly what it sounds like: communication over a single data line plus ground. Dallas Semiconductor created it in the 1990s to simplify sensor wiring, even further than 12C. Its strength is minimalism, means one wire can power and communicate with the device at the same time. Every one wire device also ships with a unique 64-bit ID, so many can share the same line without the conflict. However, its slow speed and strict timing rules makes it a poor fit for anything beyond simple sensors. And that's every hardware communication protocol explained. If you find this useful, drop a like, and if it actually helps more people to find this video, comment below which one surprised you the most. We have got more of these coming, so stick around.